Good afternoon, ladies and gentlemen, here in Silicon Valley at 13th Cloud Expo, 4th International Big Data Expo. Good morning, good afternoon, good evening if you're watching this keynote presentation out there on the World Wide Web via SYS-CON TV. This is going to be a fantabulous keynote. If you are sitting here and you know a buddy who is not sitting here but foolishly decided instead to go off and eat his sumptuous gold past lunch, text him and say, get yourself back here, because the future is about to be unfolded. What I believe is the future, and much more importantly, what Microsoft believes to be the future, and most other players beside. Let us hear from Tim Park, the Director of Platform Strategy at Microsoft, about, and it's surely the best title of any keynote that we've delivered at Cloud Expo yet, The Rise of Things. Tim.
Thank you. So I'm going to talk today about a subject that may be a little bit outside of what you are, we're kind of expecting at a conference like this. But the reason I'm going to talk about this is I think this is really important. It's something you should be thinking about as an enterprise, as an organization, as we go forward. And the reason, and to understand the reasoning behind that, we need to start at the beginning. So in the beginning, there was a computer. This is the ENIAC 1. It was something that only a large government could have, in this case, the United States. It took an army of people to operate. They were constantly changing vacuum tubes. It was something that was out of the reach of anybody else. Computers quickly, or over the next 10 years, became something that were accessible to very large corporations, very large universities. This is a PDP-11, one of my favorite all-time computers, and two of my favorite people in computing in front of it, Kernighan and Ritchie. For those of you who are developers, invented the C language. So computers became something that were accessible to these larger organizations. And of course, as we know, the trajectory from here followed the course that we've been on for essentially 25, 30 years. Smaller, cheaper, faster, more accessible. The IBM PC put this in the reach of the individual worker and then the individual person in our lives. From here, computers became increasingly portable. Started going with us between work and home. And then they became, props to our competitor Apple, but became something that were ubiquitous in our lives. So computers started to follow us everywhere, and computing started to follow us everywhere. And so this follows this trajectory that I'm trying to draw out for you. That is that computers are becoming lighter, they're becoming more ubiquitous, they're becoming faster, they're becoming more powerful, they're becoming more or less things that are always in our lives. And it's possible the next step of this is something that's on our wrist, or something that we have constantly in front of our eyes. But I think the more important thing that's going to happen over the next 10 years is that computing is going to be infused in everything in our lives. The things in our lives that we already know and love. And what makes this different, and what changes the trajectory with this, is that these things already have user interfaces. We already know how to use a light switch. We already know how to use an electrical socket. We already know how to use our coffee pot. And so what's different about this is computing is going to make those things better, but we already have expectations on how they work. And what's really fueling this is a transformation in hardware, similar to that we went through in software about 10 years ago. So 10 years ago, I would say, around about 10 years ago, at the advent of the internet, the software development became much more agile, going from a very waterfall style model to something where anybody in any garage could literally start a company, launch it on the internet, and become a big thing. I think we're going through a similar transition right now in hardware. This is a Raspberry Pi. It was built by a foundation in the UK with the goal of the noble goal of providing computing to very, very, very inexpensive computing to people in third world countries. What they didn't expect is that this would be kind of one of the pivotal points of an open hardware revolution. And not only is it being used in those third worlds, but it's also being used for developing prototypes for these Internet of Things type devices. This is just about one of a number of devices like this. There's also a very big movement behind Arduino. The Arduino allows you to prototype devices very inexpensively. And get a sense of if this thing is going to work. And so this is what hardware is starting to look like more and more now. Instead of having the top bar is more or less a waterfall model where we kind of have a specification and you do a BOM and then you design and you negotiate, you prototype, you test, you manufacture, and then and only then do you figure out if this device is going to work. We now have the kind of a more model that's becoming more and more like software, where you develop, you're able to design, rapidly prototype, test your concept in the market, do contract manufacturing, and deliver it to customers. So the cycle for hardware is becoming very small. And a good example of this, kind of the way this is changing, is a Kickstarter project that I saw. So Kickstarter, if you haven't run into it before, is a way that that folks can get funding for a project that they're working on. And this in particular is called the Good Night Light. And so what the Good Night Light is it's just a light, but it has a twist. What you do is you purchase 2 of these lights. So you have 2 physical lights, and you give one of them to a friend, one of them to a loved one. And what it might be a little bit hard to see on the monitor, but there's a chimney that comes out of this light, and when you press it, the twist to it is that it turns on the light of your loved one. And so you're able to tell your loved one that you're thinking about them by turning on their light. And so I think this is a good, this is not a canonical example, but a good example of how something ordinary, a light, has been made better with computational abilities and connectivity. And so I think this and projects like it are the future. And so before I came back to Microsoft, I was at Microsoft for 12 years. I then went out and did a couple startups, and one of them was Nest Labs. And so Nest Labs is a company that's is well known for building a thermostat. They just announced a smoke detector, and basically infusing intelligence into everyday things. And what I learned most of all from being at Nest Labs is that the Internet of Things is hard. It's really hard. And the reason it's hard is you need to do a whole bunch of upfront work before you can actually get to solving the problem you want to. And the reason behind that is you need to think about authorization and authentication and all these security-related items before you can actually start on your project, because the stakes are actually really high in the Internet of Things. If we think about the door locks, if we think about our furnace, if we think about all these kind of regular everyday things in our lives, the stakes are very, very high. If your furnace is hacked, somebody could potentially freeze you if you live in a cold enough climate. Likewise, if they hack your doorknob or your lock on your doorknob, this is a very high, exposes you to a very high level of theft. So these are things that you have to work out as part of this. Oops, sorry. Back. Another thing you also need to be thinking about is that makes the Internet of Things very hard is that these devices are very constrained, and this is a real challenge for us. I'm assuming a lot of you come from the kind of the computer industry to this. A lot of the things that we hold true, that there's always going to be Wi-Fi, there's always that these devices are always online, don't hold true in the Internet of Things. And in particular, when you start thinking about connectivity, it becomes a real difficult problem. And so this is a really complicated diagram. If you're confused by this diagram, you're getting the key point. What this is the set of low power connectivity options for the Internet of Things. And there is no real good solution right now for running a device that needs to live for 2 years on batteries, and then provides telemetry information up into the cloud. There's trade-offs from all the options. The good news is that there's a lot of work in this area going on. So the Wi-Fi, the 802.11 Standards Committee is working on a lower power version of the protocol that can, in particular, go into sleep modes and also use a lower a frequency below 1 gigahertz, which makes it easier to expand, to go between walls in your house. But there's no good solution to this. It's a very difficult problem in the Internet of Things. But one thing that is being, it has been settled on by the industry essentially is that we should use message passing. And this is really driven around that connectivity problem from the previous slide. We can't assume that devices are always connected. We can't assume that that they can connect very frequently. And so kind of a message-basing, a store and forward-based approach, it seems to be emerging in the industry. The first of these is a heavier weight protocol already in use at places like JP Morgan called AMQP. This is a standardized way of exchanging messages. And a sibling to that called MQTT, which is based or built around the idea that these embedded devices need a way of communicating as well. So that there's, in the Internet of Things, there's definitely a movement towards using a messaging-based approach to solve some of these problems. And one good way to look at this and to think about this is actually go through an example. So I'm going to talk about how a messaging approach could be used for something like that Good Night Light Kickstarter project that I talked about earlier. And so the canonical model is that they exchange messages. So if you wanted to turn on the lamp, you would send it a switch command. And if you wanted to turn it off, you'd send, or if the lamp wanted to send back state saying, "Hey, I've been turned on," it would send back a message and say it's been turned on. So this is kind of the model that people are starting to think of with the Internet of Things. It's disconnected in an IP sense, so that when the light has maybe a couple messages to send back, it can send them back, and when the application needs to send one down, it can turn on its networking and send it down. To do that, though, you need infrastructure. So if we think about this from an application perspective, you have a device that's sitting in your living room that may want to send a switch state up through a cloud service, and so you need some sort of message broker to do this. And so one kind of example of that is the service bus that we have in Windows Azure. And what that allows you to do is, if there's a number of people that are interested in that lamp switch state, it allows you to fan that out to those applications and devices. So this is an example of how you can fan this out, how you can have real-time control of these devices using some of the cloud infrastructure that's already available. But what's really interesting about the messaging-based approach is that you can build up applications on top of this. So let's say that you wanted to build an application that used that switch state in order to provide a vacation application for that lamp. And so this application would automatically turn on the lamp when you're on at the times that you normally would while you're on vacation. Because we had a message stream, we now are able to process that and essentially build up a model of when you turned on your lamp. And so an application could use that, use that history that you've built up in order to build this up. At a larger scale, even, this bears out as well. If we were building, let's say, this is an example of somebody who was building a power grid, for instance. You could use the electrical usage. The messages all coming from electrical usage. We could use the surface temperature that your subscribers were experiencing, and then use a stream-based algorithm to produce control events back to power generation to basically control it. And this is a good example of we used at Microsoft. We have a piece of infrastructure called Stream Insight, and it's well suited for these types of stream-based algorithms. And so I thought I would make all this real and then talk about how it's interesting from an enterprise perspective by giving a personal example. So this summer, I took a trip to Portland in my Subaru Forester. I'm a big fan of Subaru cars. My Subaru Forester was actually pretty old. It was about 11 years old, and of course, following Murphy's Law, it died on the trip. I'd still love the Subarus. It had a lot of miles. This wasn't totally unexpected. And so I purchased another Subaru. I'm a mountain biker, so an SUV for me is kind of required. I'd love to find a way to buy a Leaf, but the places I need to go, I need an SUV with all-wheel drive. But this time, I vowed to do something different. I am going to collect as much information about this car as possible. And the reason I'm doing that is because 2 months before my car failed, I knew something was wrong with it. It just didn't feel the same. I took it into the shop a couple times. They couldn't find anything, but I knew just from kind of instinctively having driven the car for 12 years, there was something wrong with it. And so, the way that I'm going to do this is in every car now. I don't know if many people know this. There's actually, your cars are basically computers on wheels. And you might have known that from a repair bill that you've gotten when one of those computers failed. But it also has a data bus that runs through the car. This is called the CAN bus. And it has more than 200 pieces of telemetry that are being updated every 50 times a second. And this sits underneath, more or less, under your steering wheel, at least in the Subaru cars. That's my. I took a photo of the trunk release, and it's right there to the side. And so what I'm going to do is I'm going to build, using the Arduino that I talked about before. I've built this device that can hook into that and to pull the telemetry off of it, and then I'm going to upload it to the cloud and look for variances in different and see if I can detect these issues that I felt like I probably could have. I sensed, kind of intuitively when I was driving my old Forester. What's interesting, what this illustrates though is just how much data the Internet of Things generates. And this is where we need to start thinking about the Internet of Things as enterprises. And so to collect all of this data, I'm going to collect one set of data every second. There's roughly 200 different data points that are being emitted by that data bus in my car. And so if we assume that the average lifetime of a car is 200,000 miles, and that we drive at a 40-mile-an-hour average, I don't know if those are true, but that's kind of what I feel is my average. That will end up with 3.6 billion data points, and so that kind of gives you kind of a sense of the scale of the telemetry that one of these devices can provide. Or if you assume that there's 10 bytes per data point, with indexing and whatnot, 36 gigabytes of data. And the good news is that 10 years ago, that would have been, I think, sort of a daunting amount of information. I think we would have been worried as an industry about how we process that much data. But the cloud, and in particular the technologies that are inspired by the cloud, have made it really possible to manage a set of data like this. Even though this is only one car, if you think about someone like Avis. So Avis has 5,000 locations. They probably have, let's say, 20 cars per location. So there's some really small locations. Even at that scale, we're talking about 1.5 petabytes of information. And so while that's a lot of information, if we start thinking about 10 years down the road, that's not going to be, I think, as we look out, it's not going to be that, we're not going to look at that the same way we currently do. So as they collect this, it's a structure, and the infrastructure that we put in place as part of the cloud, be it private cloud or public cloud, will allow us to manage these types of information. And if you think about it at a higher level than that, if Subaru, so one of the ideas that we've had inside Microsoft, and this applies to more than just cars, is how these manufacturers can benefit from this information as well. So if you think about Subaru collecting all this data about all their cars, they probably have a very good view and will be able to tell you when you should potentially not take it on a trip to Oregon. And so I think this is probably the most interesting thing from your organization's perspective, is thinking about how the data that may be just falling on the floor today in your enterprises could be captured and made to to benefit your organization and to provide telemetry and information that allow you to make better decisions. Another thing I wanted to talk about briefly was the structure of the Internet of Things. And so a lot of the services, the cloud services that are available today are essentially classical client-server systems. There are a couple problems with this, actually. The first one is latency. For a lot of applications, you need a level of latency that's much below that. for those of you that networking, this is probably a well-known metric, but if you send a data packet from the East Coast to the West Coast, it more or less takes 120 milliseconds to get from one end to the other. For a lot of applications in the Internet of Things, that's too long. So if you're thinking that the device essentially provides telemetry and the cloud service provides an action back to the device, that amount of latency is not acceptable. And so that's the first reason this model I don't think is the final model for how we're going to build the Internet of Things. And the second is privacy. If you thought there was a danger in sending all of your, having your email located in a cloud service, having all the proximity information about when you're home, having all your car data in terms of where you were, is just a whole order of magnitude more dangerous. And so what I think in the end will be the right model is a distributed model for the Internet of Things, where you decide which information is sent up to the cloud, and where decisions are made more locally so that we can solve the latency issue. And the final thing is the Internet of Things it presents a large challenge to us from a management perspective. Right now, the devices in our lives, I don't know about you, and many of us probably don't have this experience because we actually are really into devices. And an OS upgrade is seen as an exciting thing to a lot of us, at least for our personal devices and our consumer devices. But in the Internet of Things, we're going to reach the point where we'll be completely overwhelmed if we have to manage the upgrade of the OS on or the application software on your coffee maker. And so one of the major challenges of the Internet of Things is solving invisibly the upgrade and management of these devices. So this is an extreme example. This is, just in case you didn't believe me, this device is actually a climate monitoring station that's in Antarctica. Obviously, you can't roll a truck to it. Probably requires a multi-day trek on a snowmobile, and with about 7 inches of jacket around you. And so devices, in the real world, this is a really extreme example. But there are devices that are very inaccessible, even in your house or whatnot, are going to have to be upgradable, completely silently and without you having to actually intervene as a user or a manager of those systems. And so Microsoft has been doing a lot of thinking about this in a number of different ways. The first way we've been doing is through a program called City Next. This is more of a kind of a city-based approach to this. So City Next is the program that we have at Microsoft for helping cities get more digitally enabled. And so the way that we're working in this sense is that we're doing a lot of work around the telemetry of their traffic systems, the telemetry even of things like the post office queue lines, things like this, to make it easier and enable cities to work better for their citizens. We also have a number of Microsoft accelerators around the world. So the Microsoft accelerators help startup communities to start their products on Microsoft platforms. We have one company we're working with that was adding smarts to everyday things, and another one that's helping make factory floors more efficient. I just wanted to leave today that I don't have this all figured out, or I don't think Microsoft has all this figured out. And really, the reason I wanted to come here is kind of a start of dialogue, to understand what problems that you're seeing in your enterprise that could be solved with kind of an Internet of Things approach. And so, thanks for listening to my talk about this. Thanks for spending your lunch with me, and I'd love to talk with you more. Feel free to email me tpark@Microsoft or find me on Twitter.
Thank you, Tim, but you're not familiar with the phrase "be careful what you wish for," because
yes, I know.
You're not any chance of leaving this room with these guys.
Yes.
Wanting to ask you about goodness knows what, starting right here.
Absolutely.
How does Microsoft Internet of Things actually compare with IBM Smarter World?
So our Internet of Things is more I can't compare it with IBM's approach, but what we're trying to do is take both a very consumer view of it and a very enterprise view of it. So I think the way that, if I imagine the way we would say we're different is we're looking at both things, not just an enterprise approach, but also the consumer approach. So extending it into your house as well as instrumenting your enterprise with and making it possible with these platform things like Windows Azure Service Bus that I talked about, Windows Azure Active Directory, Windows Azure Stream Insight, and HD Insight to process the data that's generated by these different platforms. And cohesive approach, yeah.
Hi Tim, I came a bit late, but just wondering if is there any integration like with the cars and say your planner? Like, do you think cars will be able to book themselves in for a service and check your calendar and see if you're free at that time and things like that? Yeah,
so one thing I didn't mention in this is I think there's a permissions-based approach is really necessary. So when we decide we want to share information with an application in this space, I think we need to explicitly provide it access to your proximity information, maybe your calendar, and then it uses those things to make decisions. And making it very clear, I think one of the most important things is making it very clear to the user what's being used. Maybe in a manner that's analogous to the way we have with mobile now, when you're asked progressively for more permissions when you want to use certain functionality. Yeah.
Another question here.
Yep.
Hi Tim. One question that has come up a lot when talking about this sort of thing is interoperability, and how 5 years down the line we won't have 20 different things connected through 5 different systems.
Yeah, absolutely.
Do you have any insight into that?
In the longer version of this talk, I talk about the need for for coming up with a standard set of the schemas for those messages that go back and forth, and using the standards-based kind of message telemetry or messaging protocols that I talked about. So MQTT maybe being the layer that provides the transport, and then having well-defined schemas that allow different systems from different vendors to talk to each other. I think that's very important, because otherwise we won't be able to have applications that span these different vendors, and we really won't achieve the real promise of the Internet of Things if all these vendors can't communicate between themselves. And the way I liken that is I think the Internet of Things right now is at the same place we were with the Internet when we had AOL, Prodigy, and CompuServe, where we kind of had these vertical cylinders where each of them had their own strengths, but they weren't able, users weren't able to jump back and forth between them and take advantage of those different strengths. And the way the Internet, as it's developed, they can now. So I think we're in an analogous stage for the Internet of Things.
From here.
You have talked about sending messages between things, but how about event-driven,
So I think if I'm guessing where you're going with that, I think the application model for the Internet of Things will be event-driven. So you'll receive these. The application will essentially sit at the end of this message stream and react to the messages that come across to it, and generate its own messages, generate summaries of that information, and that will be the kind of these applications will be hosted in the cloud, where a cloud is defined as something that's public cloud, or maybe something that's a personal cloud that lives in your house and is hosted and waits for these messages and reacts to them, summarizes them, and does what you expect, basically.
Catch my eye if you can. Well, then I can tell you that when you kick yourself and say, oh, I've just realized what I wanted to ask Tim, he's speaking at 1:35 tomorrow in Larry Cavello's Cloud Bootcamp, so just make sure you block out 1:35 in the, where is it, Larry? Great America J.
Yes.
J. And Tim will again be singing for us. But let's please thank Tim Park for introducing us
Thank you.
to the Internet of Things. And